Hi. This is a quick announcement before you start watching that video that we're going to cover that exact same topic in tomorrow's class as well. So you can join our class using the link in the description, and I'll see you in the class. So today we're going to be doing independent and independent events. That's what we're going to start with. So two events are independent. Two events. When if one of the events does not happen, that does not affect the probability of the other happening. Now, the next thing that we're going to be doing is something called the and or rule. And this is very much related to the above part, dependent and independent events. Okay. Now, what is and or rule? And rule basically states, and rule means that if two events are independent, then let's write it in a big way. Probability of A and B, okay, if you want to find for both of them, is equal to probability of A multiplied by probability of B. This is the formula for AND rule, okay? Now, let's see a question to understand this. Dave picks one ball at random from each bag X and Y. Okay, so we have this many in X and this many in Y. Find the probability that he picks a yellow ball from both bags. Okay, so what we're going to do is, we write it here. First, we're going to find the probability that Dave picks from bag X. Okay, probability that Dave picks yellow from X, okay, is going to be what? We have 1, 2, 3, 4. Divided by how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divided by 10. Okay, in simple words, it's going to be 2 times 2, 2 times 5. So 2 or 5, that's our probability. Same thing we're going to do for Y. Probability that Dave from Y. It's going to be, we have 1, 2 divided by how many? 1, 2, 3, 4, 5, 6, 7, 8. Let me check. 1, 2, 3, 4, 5, 6, 7, yeah, 8. In simple words, 2 times 1, 2 times 4, that gives me 1 by 4. Now, how do I know that I had to use this formula? Because, look, the probability that I pick from here, it does not affect it if I pick from bag Y, because they're two different bags, okay? So it does not affect one or the other. So if I want to find the probability from both bags, okay, so probability that he picks yellow from X and Y is going to be what? 2 divided by 5 multiplied by 1 time divided by 4. That's going to give you 2 divided by 20, okay? Or in other words, you can also simplify this. Let's say you have 2 times 1, 2 times 10, 1 over 10, or 0.1. Next, we're going to study the OR rule, okay? Now, similar to the AND rule, the OR rule states the probability of one event happening, and not just one event, probability of at least, this is a keyword, at least one event happening. Okay, so the formula in this case is, let me write it here. You have probability of A or B, okay? So either A or B, either one of them happens, is equal to probability of A plus probability of B, but not just yet, minus probability of A and B. A, let me turn it here. A and B. Let me fix this. A and B. Okay, that means that for this I need to know the AND rule probability, then I can find the OR rule probability. We have a practice question here. A spinner with red, blue, green, and yellow sections is spun. The probability of it landing on each color is shown on the table. Find the probability of spinning either red or green. Okay, now what do? First and foremost, write the formula. Okay, so we have P A or B is equal to probability of A. Now what's the probability of red? It is 0.25. Okay, plus probability of B, that is green, that is 0.1. This is the tricky part. They say you also have to subtract probability of A and B. Now tell me this, can I spin a spinner, okay, and get two colors? Okay, if you don't know what a spinner is, just basically understand like this, that let's say if you roll a dice, can you get six, like one dice, can you get a 6 and a 4 at the same time? No, you can only get one at one time. So the probability of both of them happening, meaning you getting red and green at the same time, is 0. So minus 0. Okay, put it equals to here. Then you have 0.25 plus 0.1. That gives you 0.35 in total. Now the next thing that we're going to be doing is tree diagram, and we just did something before it, that was the factory, sorry, not the factory, the frequency tree. Okay, the frequency tree. Now that is close related to this because it's the exact same thing, but there are some rules that we want to know about specifically tree diagrams. Okay, everything that you need to know in, you could say, a blueprint. For example, let's say, and this could be anything, let's say you have anything, the probability that you get outcome 1 is 2 by 3. Okay, and the probability that you get outcome 2 is 1 by 3. Now if you get outcome 1 once, the probability of you getting outcome 1 again is 1 by 5, and the probability of you getting outcome 2 is 4 by 5. This is just an example. Okay, don't think why do we get 2 by 3 then 1 by 5. Just focus on what we're doing right now. So we got 4 by 5, and if for outcome 2, the probability that I get outcome 1 again, oh sorry, outcome 2 again is 4 by 5, and if I get outcome 1, I have the probability of 1 by 5. Now what if someone says find the probability that outcome 1 happens twice? What would you do? You would do, let me mark it here, outcome 1 happens once, outcome 1 happens twice. What's happening? 2 by 3 and 1 by 5. What do you have? 2 by 3 and 1 by 5. So what's happening? What you're going to do, if you're in the same branch, you're going to multiply them. The rule is written here. Multiply along the branches to get the AND probabilities. Let me also write it here. If the numbers are in the same fraction, in the same branch, multiply. If not, then add. And we're going to see example as well. So because this outcome 1 and outcome 2, this outcome 1 and outcome 1 was in the same branch, okay, then I would just multiply them. So 2 by 3 multiply by 1 by 5, and I get my answer 2 by 15. If someone says find the probability of outcome 1 and outcome 2, 2 by 3 multiply by 4 by 5. Okay, now what if someone says, let me write the question here as well, that is, question is find the probability that you get outcome 1 and outcome 2. Okay, now don't rush to this answer. You might think that, let me erase this first. You might think that, okay, I just have to go outcome 1, outcome 2. No, let me first tell you here that this is not the only one answer, that you go outcome 1 and outcome 2. This is also an answer, outcome 2, outcome 1. They did not say that outcome 1 has to be first or outcome 2 has to be first. They just said outcome 1, outcome 2. So that means I have either way of getting it. Now what do I do? Because they are in different branches, outcome 1, outcome 2, and outcome 2, outcome 1 are different branches. What do we do? That's what I'm here to explain to you. So what we're going to do is first find out for this one, that's 2 by 3 times 1 by 5. Okay, so 2 by 3 times 1 by 5, that gives me 2 by 15. Then let me write it here, outcome 1 and outcome 2. Outcome 2 and outcome 1 is what? Outcome 2, outcome 1, 1 by 3 times 1 by 5, 1 by 15. Now what do we do with these two answers? Add them. As I said, if these two are not in the same branch, then what do? Add them. So 2 by 15 plus 1 by 15, answer is 3 by 15, or in simple words, 3 times 1, 3 times 5, 1 by 5 is our final answer. Now, next thing, now there's also special case in tree diagrams. Okay, a special case, let me write that here. Watch out for at least based questions, and I'm going to explain why. Okay, I'm also going to tell you what is the formula, or what is the way basically on how you tackle these questions. Now we have a question here. Let's say I roll 3 fair 6-sided dice. Find the probability that I roll at least 1 6. At least, where's the probability? I wrote at least 1 6. Now, instead of finding the probability of at least 6, what you're going to do is you're going to have a formula like this. Probability of at least 6 is equal to 1 minus probability less than 6. What does that mean? Remember, probability is always 1. Probability total is 1. So if you want to find the probability of 6, meaning that you get at least 6, the probability of you not getting, for example, let's say if I frame it like this, let's say that you want to find the probability that you get 6. Okay, find out the probability that you don't get 6 and then subtract that from 1, because the remaining would be for 6, because you know what the total is. Okay, and the simplest way to understand this would be that understand that, let's say you know that a total amount I have is $1,000. Okay, I gave Jack 500. How much did I give Amy? You would say total minus Jack's, so that's going to be 500. So you know the total, you know one part, and you can find the remaining one. So that's what you want to do. 1 minus probability less than 6. Okay, probability less than 6. Now what you're going to do is first make your tree diagram. Okay, because that's what this all was about. So first, let's say you roll a dice. Okay, you have two possibilities. You get a 6 and not a 6. Probability you get a 6 is 1 by 6. Probability you get not 6 is 5 by 6. Then you do not get 6 again. Okay, the probability of you getting a 6 again and not 6 again, because that's what we want to find, the probability that you don't get a 6, 3 in 3 dice. So we're going to do this 3 times. You get 6, 1 by 6, not get 6, 5 by 6. Again, that you get 6 and not 6 is going to be 1 by 6 and 5 by 6. What do you want to find? Probability less than 6. So less than 6 is going to be what? 5 by 6 times 5 by 6 times 5 by 6. Why? Because they're all in the same branch. That's why we're going to multiply them. So 5 by 6 times 5 by, and remember, don't go to the mistake of doing 5 by 6 times 3. Okay, that's going to be a big issue. This is 5 by 6 times 5 by 6 times 5 by 6, not times 3. So you cannot do that. So the final answer will be 5 times 5 is 25. 25 times 5 is 125. 6 times 6 36. 36 times 6 is 256. Now again, do not mistake this as your final answer. Why? Because this is the probability less than 6. You're finding probability of at least 6. So we're going to do probability at least 6, 1 minus 125 divided by 256. Sorry, this was not 256, this was 216. I mixed this up with the other part. 216. 216. And this gives you 91 divided by 216 as your final answer. If you watched the video till the end and you still have some questions about the topic, we're going to cover that exact same topic in tomorrow's class, and you can join that class by joining the link in the description. Okay, I'm going to see you there.